Let's try that again. Alright, so let me try that again. So again, after we solve those, we have our two special triangles. The special triangle, when it's 45, 45, 90, always has lengths of 1, 1, and square root of 2. We're just going to be dealing with these two triangles today. The special triangles for 30, 60, 90 always have lengths of 1, 2, and square root of 3. Now, how do I determine what's what? Well, look, it makes sense that if 45 and 45 are the same, that the side across them should be the same, right? Okay? And this one we found by finding the Pythagorean theorem, but you're just going to have to memorize that square root of 2. On this one, the smallest angle always across from it is the smallest side. And so 1, the smallest side would be across from the smallest angle. What's bigger, 60 degrees or 90 degrees? What's bigger, 60 degrees or 90 degrees?
90.
90 degrees. So 2 is across from that. I'm here to tell you that the square root of 3 is like 1.7 something. That's between 1 and 2. So it makes sense, kind of like baby bear, mama bear, papa bear. Smallest, medium, big, okay? With the sides across. So, now with that being said, I can do SOHCAHTOA for these triangles. For instance, sine of 30. Well, look at this triangle. What is the sine of 30? Well, let's label, what is sine? So, it's opposite over hypotenuse, right? So from 30 degrees, what's my side opposite? Oh, opposite over hypotenuse. 1. From 30 degrees, my side opposite is 1. What's my hypotenuse? 2. There's my answer. 1/2. Done. Okay? Let's look at sine of 60. Sine of 60 is from 60 degrees, opposite, which would be square root of 3, over hypotenuse, which is 2. Is that okay? Can I have a square root on top?
Yeah.
Yes. Can I have a square root on bottom?
No.
No. We'll talk about that on the next one. So square root of 3 over 2 is legit. That's my answer for that. What about sine of 45 though? Well, sine of 45, so from, now I'm going to go to the other triangle because it's 45 degrees, and pick either of the angles, doesn't matter. I go opposite over hypotenuse. So I'm going to have 1 over the square root of 2. And we just got done saying, sorry, you can't see that. We just got done saying we can't have a square root in the denominator. So how do I fix that?
You do square root of the top and bottom?
Do the square root of 2 to the top and bottom. So I'm going to do square root of 2 here and square root of 2 here. What's 1 times the square root of 2? Square root of 2, yeah, don't confuse it, it's just 1 times square root of 2 is square root of 2. Over, what's square root of 2 times square root of 2?
2.
2, because it would be square root of 4, which is 2, and that gets rid of our radical in the denominator, and that's the answer. How about you guys to try the rest? It's going to take a few minutes, okay? But again, maybe start with a fraction bar for all of these, because you're talking about opposite over hypotenuse, adjacent over hypotenuse, or opposite over adjacent. And then reduce them if you can reduce them. By that I mean don't have a radical in the denominator. You can have it on top, you can't have it on bottom. Go ahead and try those. Now we're getting better at the SOHCAHTOA stuff. Go ahead, keep working. I'm going to start throwing some of them up there. check your answers to mine, or you can just kind of copy them in. I just want to make sure that you're feeling okay about this. Okay, so we have to go to the angle and determine what's my opposite and adjacent, my hypotenuse, and then determine what those values are from there. Any questions about 1 through 9? I'm going to tell you, yeah, go ahead, Trey. Okay, I'm going to tell you going forward, and I did not do it right now. All of these answers are correct. Every once in a while, I'm going to throw a wrong answer at you. So if you're looking at one, you're like, wait a minute, I didn't get that. These are all correct. But if you're looking at one in the future and you're like, wait, I got something different, call me out on it, because I'm going to do it intentionally. Okay? All right, down at the bottom. When I look at these points here, all I want to do is determine where it's positive and negative. So if I'm in quadrant 1, this point right here, somebody give me the value just approximately of what that point is right there. Over what and up what?
6, 5,
6, 5, 5, 6, whatever. The point is they're both positive. So positive, positive. Everything in that quadrant is positive for x and positive for y, right? Can somebody tell me what it is in quadrant 2? What would my x value be? Negative because I go to the left. What would my y value be? Positive because I go up. Fill in the other two real quick. Now I do this every single year, and you guys remember this, but when we get to the next page, you're going to forget. What I'm trying to say is, when you go left, x is negative. When you go down, y is negative. That's really what I'm trying to accomplish with this. Okay? Just remember that. Let's go to the next page. Alright, so there's 5 steps to every one of these problems. Once you see a couple, I promise you, this is not going to be very difficult. And it deals with reference angles. So, first things first. For angles other than 30, 60, 45, so if it's exactly 60, we can just draw that triangle. If it's exactly 30 or 45, we can just draw the triangle, we're done. But for other ones, we got to do the following. First, find the angle of rotation. So if I look at number 10 and I say cosine of 150 degrees, where would I draw my line for 150 degrees? Where would it be approximately, like between what and what? Matter of fact, can you remember the quadrants? Which quadrant would it be in? Quadrant 2, right? Because if everything starts here, how many degrees is it to get to here? 90. How many degrees to get to here? 180. So 150 is like somewhere in between there, right? Now I'm not asking you to draw perfect because your labels are going to help you. But 150 degrees would be somewhere around there. And that's your first step. We're going to do 3 problems at the same time. We're going to do 11 and 13 as well. Where is, so counterclockwise is positive, clockwise is negative. So where do I got to put negative 60? Go ahead. Down, right? So if positive 60 would be up here, negative 60 would be right here. How many degrees is this again? Negative 90. So I don't want to go that far. So I'm going to draw it right over here. And for 12, and the reason I'm doing 3 at a time is because I want you to see it's the same steps over and over and over. For number 12, cosine of negative 225. So do I got to go clockwise or counterclockwise first? Clockwise is negative. Clockwise is negative, okay? So let's see. If I start here and I go to here, how many degrees? 90, how many degrees to here? 180, how many degrees to here? 270. So it's got to be like right in between those, right? So let's put that right in between those. I meant to actually do number 13. But that's okay. We'll give you that one. And I'll give you this one too. 120 is going to be right around there as well. Why? Because 90 is to the first one, 180 is to the second one, so 120 is going to be in between. Okay? So there's my first step. Draw the actual angle. Okay? Second step. Draw a perpendicular line back to the x-axis. This is called creating a reference angle. Okay? So from the arrow, just draw a line right down to the x-axis. From the arrow, just draw a line up to the x-axis. From the arrow, just draw a line down to the x-axis. From the arrow, just draw a line down to the x-axis. Quite see that. I'm using the arrow just a little. Okay. Now, perpendicular line means, what is that angle? Remember from geometry, what does perpendicular mean? What kind of angles do they form? 90-degree angles. These are all going to be 90-degree triangles. So what happens here is, let's label this right away. Let's put a little box in each one of these. 90-degree angles in all of them. Okay. Now again, never, ever, ever do you connect it to the y-axis. It's always back to the x-axis, and that's why we did reference angles yesterday. So you realize you're just going back to the x-axis. Okay? You never connect it to the y-axis, always to the x-axis. And I say that at number 3. Now to find the reference angle, well, again, how many degrees is it from here to here? 90 degrees. How many more degrees do I have to go to get to 150? 60 more, right? So this is 60, which means, what is this inside the triangle? How do you know it's 30? Well, you're right. How do you know? How?
90 minus 60.
Right. This whole thing has to be 90 degrees, right? So if this is 60, then that has to be 30. Okay? How many degrees are in a triangle again?
180.
180. So if I take away the 90 degrees, I have 90 left. Minus 30 means what's this?
60.
60. All of these are going to be either 30, 60, 90, or 45, 45. So if you have 30 here, then that automatically is 60 up there. Okay? Okay, so I've labeled my triangle. Let's go on to the next one and do the same thing. What is this right here, inside the triangle?
45.
Here's the question. Is it 30, 45, or 60? 60. How do you know it's 60? Because it says it's negative 60. From here to here is negative 60, so that's 60 degrees. So what does that make this one? 30. Now I'm starting to see a pattern. Let's do number 13 too. Okay, so again, this one's a little harder. What is it from here to here again? 90. How much more would get me to 120? 30. So what's this on the inside? 60, which makes this 30. Okay, look at number 12 though. This is a little different. From here to here is how many degrees? 180, right? And it's negative. How much more do I have to go to get to 225? Well, could I just go 225 minus 180?
Yeah.
Subtract it, I get 5, borrow, 4. Oh, so this is 45. So what does this one have to be? 45. Again, they are all going to be either 30, 60, 90, or 45, 45, 90. That's kind of hard to see, but that's a 45. All right, cool. So we labeled our graphs, we labeled our angles. So I'm through step 4. Use the triangles to find sine, cosine, or tangent, which means I'm going to draw them back up here. Our 2 triangles from the very first page. I've got 30, 60, 90. Across from 30 is 1. Across from 60 is square root of 3, and that's 2, excuse me. And then in the 45, 45, 90. 45, 45. And again, this is just from the first page. Do you remember what the 2 sides were? 1 and 1. And do you remember what this one is in? Square root of 2. Okay, so you already got this. Okay, so let's go and label our triangle. So in number 12, this is 1, 1, square root of 2. In the rest of them, we got to be careful which one's going across from what. What goes across from 30 again? 1, yeah, just look up here. Across from 30 is 1. So across from 30 is 1. I'm going to go all the way through. Across from 30 is 1. Across from 30 is 1. What's across from 60? Square root of 3. So across from 60 is square root of 3. Across from 60 is square root of 3. Across from 60 is square root of 3. And then the hypotenuse is always what? 2. You can look up here again. Hypotenuse on those 30, 60, 90s is always 2. On all of them. Okay? Now, remember, what did I say in the previous page? If you're going left, it makes x values what? If you're going left, the x values are negative. And similarly, if you're going down, the y values are negative. So, let's just go through, and anytime you see left or down, it has to be negative as well. So right here, I went left, that's negative. Up, is up negative? No. What about to the right? Is that negative? No. What about down?
Yeah.
Yup, so this one has to be negative. What about here? Is left negative? Yup. Is up? No. Left? Yup. Up? No. Now, if I have one down here, then it has to be negative and negative. The hypotenuse is never negative. Let me say it again. The hypotenuse is never negative. And it's because of Pythagorean theorem. You would square the one, you'd square the other. If you add them together, they're both positive. Okay? Don't need to know why. You just need to know never, ever, 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 ever is the hypotenuse negative. Okay? Now what? Now it's just find the cosine, sine, or sine. And you're just doing it from this angle. So from this angle, let's label it. This is my side opposite. This is my side adjacent. And this is my hypotenuse. Well, I want to find the cosine. Cosine is adjacent over hypotenuse. What's the adjacent value here? Negative square root of 3. What's my hypotenuse? 2. That's it. We did all that work to get that answer. How about the next one? Can somebody tell me the answer for the next one then? Maybe let's label it. We're going from the 60, so we're always going from the angle that's attached to the axis. This is my side opposite. This is my hypotenuse. This is my side adjacent. What 2 do I need for sine? Opposite over hypotenuse, so the opposite is negative square root of 3, and the hypotenuse is 2. Just so happens it's the exact same answer. You guys try 12 and 13. We'll come back to the other ones. All I want you to do is tell me what's the cosine of number 12 and what's the tangent of number 13. Don't make it harder than it is. Look at the values you have. Do what you need to do for SOHCAHTOA. So again, the angle you're using is always the one that's attached to the x-axis and the y-axis. It's always attached to the origin. So if you label your triangle from there, it becomes pretty easy. When you're done, check your answers in mine. If you're not getting what I'm getting, call me over. Let me show you what you're doing wrong. How we doing? Feeling okay? Because it's not going to get any harder. You guys try 14 and 15 on your own then. Try 14 and 15 on your own. Okay, I've got my work and my solution up on the board. Please make sure you got those two correct before you move on. And then your homework is the next 2 pages. It's 12 problems. You know what? I'm going to change it. Let's do 1 through 10 instead. So you can scratch off 11 and 12. Actually, don't scratch them off, because if you do something wrong, I'm going to want to try those tomorrow. So just don't do 11 and 12. Just do 1 through 10. Okay? Homework is 1 through 10. Again, if you got these right, you know what you're doing. Go on to the homework. If you don't, let's please talk about this before you move on.